Okay, we will continue with question 39, and for this video we will cover the last few questions of paper 1, which is 39 and 40, so it's going to be a short one. So let's begin with 39. So 39, it is actually a potential divider involving a light dependent resistor. So content knowledge wise, you should familiarize yourself with how the light dependent resistor changes with light intensity. So for this LDR, what happens is that if your light intensity increases, the resistance will actually decrease for the LDR. Okay? And the other piece of content knowledge that you need to have is how voltage is being shared in a parallel connection and a series connection. Okay, and finally, you also need to know that what is the parameter deciding that will affect brightness, because you are asked to evaluate the brightness. So the brightness is actually a form of light energy, and so brightness is related to the power of each light bulb, because power is given by the rate of energy being released per second. So if you have a higher power, then you will have a brighter light bulb. So power is given by many formula, and this sometimes would cause a bit of confusion as to which formula you need to use to evaluate the situation. So the three formula of power is given as such: power equals to V times I square R, and finally V square over R. Now the problem with this is that there's no rule that will help you decide which formula to use. So you really need to study the situation. And if you look at the circuit here, you are not given the current at all, but since it is a parallel connection mainly, you would have known that, oh, because L2 is connected parallel to your battery and these two are actually connected in parallel to your battery, it would be easier for you to use the voltage to evaluate the brightness, because you need not calculate the I in this case. So therefore, in this discussion, we are going to use P equals to V square over R to evaluate our circuit. So what happened here is that I have redrawn the circuit into this. They are the same. I'm just shifting this L1 board down this wire. Okay, because you all are used to looking at circuit that are regular like this. Now let's evaluate L2 first. So L2 is connected in parallel to the battery, meaning that the potential difference across L2 is dependent on the battery alone. Whether this R increase or decrease, it will have no effect on the potential difference of L2. It only depends on the battery's EMF. So in this case, we would have already eliminated two of the MCQ given to us. So now let's analyze the lower branch. So as I have said earlier, the resistance of the LDR will change according to the light. And since your question says that the light intensity actually increased, so therefore we can say that since the light intensity increased, the resistance here will decrease. And because your R and your L1 is connected in series, meaning that the voltage across these two is going to be shared by L1 and R, and the sharing depends on the resistance of each component. The higher the resistance, the greater the share. So since now your the resistance of R has decreased, so therefore its share of voltage will naturally decrease. In another word, it also means that now your voltage across L1 would increase. Now, if you have forgotten a Y, then remember the V of this and the V of this must add up and equal to this. So therefore, if there's a drop in voltage across L, there will be an increase of voltage across L. And since P is equals to V squared over R, so therefore the brightness of L1 would increase. Yeah.